what is normal random variable or normal distribution or Gaussian distribution, how it is applied and where it is applied. The highest point on the curve or the top of the bell represents the most probable event in a series of data, while all other possible occurrences are equally distributed around the most probable event, creating a downward sloping line on each side of the peak. So the value over here 0 is representing the average or mean value, and this peak over here is representing the most probable event. Why this mean is 0 and what these values 1 and -1, -2 are representing, we will talk about it later. Here we just try to understand what is the meaning of this shape over here. So this shape over here represents that the most probable event is in the middle over here, and the probability of all the other events to occur above or below it are equal. So the probability for an event at 1 is same as the probability of that event to occur at -1. So the probability is the same, and the shape of this curve is like a bell, so that's why it is called bell curve shape. The bell shaped curve appear in many applications of probability theory. We'll see where this bell curve shape or normal Gaussian random variable can be applied later on. This curve over here has got a significant meaning as well. So this normal distribution over here has got values mu is equal to 2 and sigma is equal to 1/2. Mu is the mean or average, and sigma is the standard deviation. Here we can see the value of the mean in this for this graph over here, and for this one are the same. Means are the same. Mu is equal to 2, and here mu is also 2. But the standard deviation is different. Here sigma is equal to 2, and here sigma is equal to 1/2. Here we can see the dispersion is more, and here the dispersion is much lesser. So what is the meaning of that? It means that for an event to occur near this average value, in this case is more probable than this one, because the dispersion around this mean value is much higher. X is a Gaussian random variable if the PDF of X is the PDF probability density function for normal distribution is given as f of x is equal to 1 divided by under root 2 pi sigma square multiplied by e raised to power minus x minus mu whole square divided by 2 sigma square. And this value over here 1 over 2 pi root is there to make sure that the area under the curve is equal to 1. We have talked about it in previous video that the area under this curve must be equal to 1. The graph of f of x has a bell shape where the center of the bell is x is equal to mu. That's what I have told you, that this is the mean value. 2 over here it is the mean value. Sigma reflects the width of the bell, whether you call it dispersion or width of the bell. As you can see, the width of the bell over here is much less than this one. If sigma is small, the bell is narrow with a high pointy peak, and if sigma is large, the bell is wide with a low flat peak. So here you can see that the bell is narrow and sigma value is 1/2. When sigma value is large, sigma is equal to 2, then the bell height of the peak is 1 divided by sigma multiplied by under root 2 pi. Expected value is equal to mu, as we have seen, and variance is equal to sigma square. The entire distribution is characterized by the first two moments of the variable mu and sigma square. Having these two moments, one can obtain the precise position of the PDF. So if x is a Gaussian random variable, then the CDF of x is phi multiplied by x minus mu divided by sigma, and the CDF of the standard normal variable z is equal to 1 over 2 under root 2 pi integral from minus infinity to z e minus u square divided by 2 u minus u square divided by 2 du. Now where we can apply this normal distribution? Many things closely follow a normal distribution, like heights of people, size of things produced by machines, errors in measurements, blood pressure, and marks on a test. They all have got this normal distribution. Means that the average has got the highest probability. In all these cases, the average value has got the highest probability. The normal distribution has mean is equal to median is equal to mode. There is symmetry about the center. We have told you that there is symmetry about the mean. The probability for all the events above this mean value and below this mean value is the same. And 50% of values less are values less than the 50% of values are less than the mean, and 50% values are greater than the mean. First standard deviation. What is first standard deviation? About 68% of the area under a normal distribution curve lies within one standard deviation of the mean. It means that if mu is the mean and sigma is the standard deviation of the distribution, then 68% of the values fall in the range between mu minus sigma and mu plus sigma. So here you can see that 34% values are will fall in this region, x plus x from x to x plus sigma, and 34% will fall from x mean value of x and x mean minus sigma, or you can say mu. This x bar is actually mu. So mu minus sigma and mu. So altogether this is from here to here, it is 68%. Second standard deviation means about 95% of the values lie within two standard deviations of the mean, that is between mu minus 2 sigma and mu plus 2 sigma. So mu from mu to plus 2 sigma and from mu to minus 2 sigma, the values will be altogether from here to here, it will be 95%. In this area from sigma mu minus sigma to minus 2 sigma, it is 13.5%, and here again it is, since it is symmetry, then again it is 13.5%. Altogether it is 27%. Third standard deviation, about 99.7% of the values lie within three standard deviations of the mean, that is between mu minus 3 sigma and mu plus 3 sigma. So from here minus 3 to plus 3, it is 99.7%. The number of standard deviations from the mean is also called the standard score, sigma, or z-score. So how do we sketch a normal distribution graph? First find the mean mu and the standard deviation sigma. Then find second standard deviation and third standard deviation. Add and subtract sigma, 2 sigma and 3 sigma from the mean to get right and left points. And now calculate normal distribution PDF for all the values of x, mean and standard deviation by using this PDF formula which we have seen before. So suppose students result is x is equal to 20, 15, 26, 32, 18, 28, 35, 14, 26, 22 and 17. These are the marks obtained by students. Mean of this is 23 using this equation, and standard deviation is 6.666333 using this equation. Sigma is equal to under root sum of x minus mu I divided by n. The square is missing over here. So first standard deviation is 23 minus 6.66. We just subtracted this value of sigma, and it is 16.33, and it will be on the left hand side, on the left hand side of the graph over here, this one. And 23 plus 6.66 gives us 29.66. Similarly, second standard deviation, 23 minus 2 multiplied by 2 into sigma is equal to 9.66, and 23 plus 2 into 6.66 gives 36.332. And similarly, this third standard deviation is also calculated. These values which we have calculated here are shown over here again, 16.3629, and these values are plugged in to this PDF equation over here. So now we know that what is 2 and pi are constants. Sigma value we already know, it is 6.66 e raised power minus x. Now this value of x will be different for each one. For example, first we will place 23, then this 16.33, 29.6. So different values, putting these different values of x over here gave us these values over here, f of x. And finally we have obtained these values. At 23 we have got 0.05984 f of x. This is this one, 0.05. And I told you this, how we achieved we got this value by putting this 23 over here, this one over here. X becomes 23 over here. So after plugging these values for x, we have achieved these values of f of x, and then we simply plotted these values on this graph over here. And for rest of the values, like because these values are only for first standard deviation, second and third deviation, but we have to find the values for 20, 15, 26, 32. So for that we have used this one, 14, 15, 18, 20, 22, 26, 32, 35. These are the values over here. We have sketched these using these values over here. We have got this bell-shaped curve. So this is how we draw the find the values of f of x, and then we draw it on the graph paper. Now what is standard normal distribution? The standardized value of a normally distributed random variable is called a z-score and is calculated using the following formula. Z is equal to x minus mu divided by sigma. We know the mu is mean, sigma is standard deviation, and x is the value which is to be standardized. So this is a normal distribution which we have converted to a standard normal distribution, and as you can see, it does not change the shape of the bell. It simply standardize the normal distribution, and we will see why do we standardize it, and what's the advantage of standardizing or getting standard normal distribution. So first of all, we see how do we achieve these values of z over here, these values. So imagine you have a random variable x that is normally distributed with a mean of 20 and a standard deviation of 10. What would be the standardized z-score of x is equal to 40? So we just simply plug in the value of x over here, which is 40 given in the example, subtract mu, which is 20, and divided by sigma, which is 10. So this gives us 2. So the standardized value z-score of 40 is 2. So suppose here you have got a value of 40 over here, then here it will be this 2. The z-scores are important because they tell you how far a value is from the mean. When you standardize a random variable, its mean becomes 0. So as I told you in the beginning of this video that we will talk about this 0. How do we get this 0? Actually, this 0 is representing the mean value over here. 1 0 1 0 is becomes 0, and it is quite evident from this one over here, because here when you will place the value of x same as mean, because you want to get the value z-score of mean. So here it will be the same. 20 minus 20 is equal to 0, divided by 10 is equal to 0. So z is equal to 0. So if the z-score of x is 0, then the value of x is equal to the mean. If the z-score of x is plus 1, then the mean value of x is 1 standard deviation. We have talked about it, that what each this one represents: plus 1, plus 2, plus 3. This is first deviation, second deviation, third deviation, and it is equally the same on the left side. Now we will see an example. A survey of daily travel time had these results. The results are given in minutes: 26, 33, 65, and so on up to 34. These are different values. The mean of these values is 38.8 average, and the standard deviation is 11.4 minutes. This is important. Like here I can write this unit with this standard deviation. If it had been a variance, then I could not have written the units over here. Solution: let's find z for the first value of the given data, that is 26. So for this value over here, 26, we get z is equal to minus 1.12, and if we find the z value over here for first standard deviation, second, third standard deviation, then I'm not going to explain how did we achieve these values of f of x, because I have explained you over here in this example. We have talked about it. It is the same. So up to this point, the method to get f of x is same as in the previous example, but now we will get this standard deviation, standard normal distribution, SND, is equal to x minus mu over divided by sigma. So we simply subtract this 27.10 from 38.8, which is the mean, and divide it by the sigma, and it gives us minus 1, 1, minus 2, 2, minus 3, and 3. Now we have to find the other values for 25, 26, 28 for these values over here. these values over here, and then we have plotted these values over here on this graph. So finding probabilities, we need to integrate the PDF over the range of values. We have talked about it previously, that to find the probabilities we have to find the we have to integrate the PDF, because these values over here are not the probabilities. The area under these values is the probability. So we have to take an interval and then we have to integrate it to get the area, and that will give us the probability. To avoid integration, we can rely on the standard normal distribution. The standard normal distribution is a special normal distribution with mu is equal to 0 and sigma is equal to 1. So this is the advantage of normal distribution, that we get rid of doing this integration. We can use the z-score to standardize any normal distribution, any random variable, converting the x values to z-scores, thus allowing us to use probabilities from the standard normal table. So how do we find area under the curve associated with a z-score? Answer is standard normal table.